Okay, features and limitations of least squares regression lines. So this is section 4.1. So last time you learned about how to compute for coefficient of correlation, that is your R. And 4.2, you learn how to get the least squares regression line, the equation of the line. Same thing with the use of the slope and the intercept. So for tonight, for this section 4.3, objectives are, number one, understand the importance of avoiding extrapolation. Next, compute residuals and state the least squares property. Next, construct and interpret residual plots. Then determine whether outliers are inferential. And then compute and interpret the coefficient of determination. So objective one, understand the importance of avoiding extrapolation. So remember our example last time, we use the size of the houses versus the sales price. And we got these points and also the equation of the line. So making predictions for values of the explanatory variable that are outside the range of the data is what you call the extrapolation. So copy that. In general, it is best practice not to use the least squares regression line to make predictions for X values that are outside the range of your data, because the linear relationship may not hold there. So just like exactly this example here, so you have this line here. We have this equation of this this line, but we cannot assume that this is the case for all the house sizes. It doesn't mean that if you have this equation of the line, let's say 4,000 square meter is going to be this much, like maybe this is 700,000. It's not always going to be like that. Let's say if you have 10,000 square feet, it's not going to be like a million, right? So there will always be, it's not always going to be a line. So that's why so the best practice not to use the least squares regression line to make predictions for X values that are outside the range of the data. So just like this data. Okay, next one is how do we compute our residuals and state the least squares property. So first, how do we compute this? So again, we're using the same example here. So you know our equation is y hat is equal to b0 plus b1x, whereas b1 is the slope and b0 is the intercept. So for example here, the least squares regression line for predicting the selling price, this we got this last time, our equation, 160.1939 plus 0.0992x. Excuse me. We may compute the residual for the point. So look at the point here. This was the given, and this point is at 2,555 and $426,000. So the size of the house, 2,555 square feet, and the price 426,000. So we may compute the residual for the point 255,426. That is, if you plug in 255, so this is our line. So if you plug in 255 to our equation, you will get 413.6, meaning $413,000, $1,000.6. So So comparing these two values here, 426 and 413.6, and we will be able to compute for our residual, that is getting the difference between the two. So 426 minus 413.6 is 12.4. So that is how you get, or how you compute the residual. How many points do we have here? 1, 2, 3, 4, 5, 6, 7, and 8. So if we do that for all 8 points, meaning for this, for this, for this, for this, this, and this, getting the difference between those, the y values and the predicted values, and for all 8 points, that's a lot, right? But I'm going to show you later the shortcut for this. So I'm just showing you how to compute for the residual. So we don't really need to do all this for every point. And we have the least squares property. I actually already explained it. So the magnitude of the residual is just the vertical distance from the point to the least squares line. So just like what I showed you earlier. So it's from the point, draw a vertical line to the line. The least squares line is the line for which the sum of the squared vertical distances is as small as possible. It follows that if we square each residual, just like the last one, if you square that, and if you do the same thing for all the 8 points and add up all the squares, the sum is less the least squares regression line than for any other line. And that is what we call the least squares property. So again, we got the difference between the two here. If you do it for all the points and getting the squares for each and getting the sum of all those 8, that is the least squares property. Okay, how do we do it and how do we plot it? So for each of those points, like 12.4 and the rest, you're gonna plot it, and that is what we call the residual plot. So I want you to copy this. A residual plot is a plot in which the residuals are plotted against the values of the explanatory variable x. And take note of this too. When you see a linear relationship about those points, then the residual plot will not exhibit any noticeable pattern. When you graph the residual plots, the residuals, you won't see any pattern. If the residual plot does exhibit a pattern, like curve, then it does not have a linear relationship. And you should not use the least squares regression line. Okay, it doesn't mean that when you use that shortcut, stat calc 8, and if you see your R, like R is very close to 1 or very close to -1, it doesn't mean that it is linear. That's why it's the best thing still is to construct either a scatter plot or a residual plot, because you will see if there is a pattern, if it forms a line or not. Questions? Any questions? All right, so this is the same example that we used last time, and I'm just showing you how to compute it the residual plot, but we're not going to use this. So first you get the predicted value for each, and then subtract y minus y hat. That's why you get all these numbers here. And so this is the residual plot. So look at the first one, negative 10.28. So when you subtract this to 400 minus 410.27, it's approximately negative 10.28. And if you graph that, you have 25, 21, which is the size, and the residual is negative 0.28. So from 0, that's why you have it here. Below 0 is a negative. Next 12, 255, when you get the difference between the two is 12.35. So that's why you have this point, and so on and so forth. So the residual is, the center should be 0, above positive, below negative. And look at all these points. We don't see any pattern here. So if you don't see any pattern, so the use of the least squares regression line is appropriate. Questions so far? I'm sure you're asking next, how do we use a graphing calculator to graph this? Because I don't want you to compute, add 2 columns here, and then graph like this, right? So let's do it. So it's my, sorry, I forgot my graphing calculator. Where is it? Oops. All right, so this is our graphing calculator. So stat 1. So we still have all this data here. So just to recall again, for scatter plot, second y equals, and then 1, turn it on, make sure that you have the x list and the y list. We entered those into L1 and L2, and then to graph it as zoom 9. So we have those dots. And then to get the equation of the line, just to recall that stat calc 8, and make sure again that you have those lists, L1 and L2, and then calculate. You'll be able to get your A and B. So that's why you have to write it in this form: y is equal to a plus bx. And after that, you type that your equation, so press y equals here, and this is your equation: 160.1939 plus 0.0992x, and then just zoom 9 or just press graph again, and you will see this line. Okay, so that's how you get the scatter plot and the least squares regression line. So for the residual, so all you have to do is just go just like your scatter plot. So second y equals, so 1. So make sure that it is on. List 1 is X list, but this time you have to change your Y list. So your Y list, to change it, to change your Y list, so second stats, okay, 7. So I'm gonna write it down here. So residual plot. So to get your residual plot, just like your scatter plot, so second y equals second y equals, and then 1. Make sure to turn it on, and then you will see X list is your L1, and your Y list is, this time you have to change this. Wait, I'm just reading the chat. Yes, there is a discussion, because 4.3 and 5.1 are short sections, so meaning we will be able to have time to work on some short discussion. So yeah, so check, there will be a discussion activity. So while this, you need to change it to residual. So how do you change it to residual? Second stat, and then choose 7. Yes. Okay. Where's my? So let's do that. So with the second stat, then choose 7, and there you go. You already changed the Y list. Instead of L2, it is now residual. And then zoom 9 or graph. Wait. Zoom 9, sorry, zoom 9. And this is your residual plot. Any questions? Oh, there's a question here. If you're not using this shortcut, if you don't have residual, because there are some calculus without the residual, without this option, then you need to calculate a residual into L3. Yes. Or L4. So what we're going to do is, can I erase this now? Yeah. You're gonna need to go back to stat1 to your table of values here. And so remember, this is your X and this is Y. This should be your Y hat, and this is should be your residuals. So how do we get the Y hat? We have an equation. What was the equation again?
Wouldn't it be L1 minus L2?
Yes, that's no, that's for residuals. No. Y hat a formula. You can go back here. Yes, I'm gonna. So 160, your equation, 160.1939 plus 0.0992x. So you're gonna need to use that. To start one. So it's like a long method here. So to compute for your Y hat, go to L3. So you should highlight L3 here. You see the black highlighted L3. And here you type this 160.1939 plus 0.0992. And your X is, look at this, the first column, that's all your X values, your L1. So meaning 0.0992 times your X values. So times your X values, that's your L1. To get L1, that you see L1 here, the blue, so second one. So again, you need to type the equation times L1, then enter, you will get those answers. Okay? Next, we're not done yet. That is only Y, that's only the Y hat. So for residuals, so just like the one that I showed you earlier, the table, residual is Y minus Y hat. Where's my marker? Right? I don't want you to subtract each number here. So you can do is, again, go to L4, highlight that L4, and then type it here. Where is your Y? Your Y is L2, and your Y hat is L3. So meaning second 2 minus second 3. Did you get that? And then enter. Those are the residuals. So the formula Y hat is, the formula of Y hat is from, remember, from here. And Y hat, we got that from StatCalc 8. It's the equation. So from here, you will be able to write the equation. So A is 160.1939, B is 0.09912x, right? So after you get the equation, so when you go back to your data, so you will be able to compute for the Y hat of all this, of all with the X values. So what we did is you type this times L1. Repeat what? Repeat which one? Repeat the L2 and L3. Okay, L3 is from the equation. How do we get the equation? L3 is, as you can see on top here, y hat. How do we get y hat? After you enter into L1 and L2 is stat calc 8. You will have this, right? You know how to get the equation. Yes? You all know how to get the equation.
Yes.
Yes.
So you go back to your table. So L3, what you do for L3, which is your y hat, I'm gonna, like, your y hat is your L3. Okay, your L3 is the equation, your A plus B times L1. So that's why you go up, sorry, you make sure to highlight L3, not on this, not on the first line, not here, make sure on the top. Make sure to highlight L3, and now you enter the equation 160.1939 plus 0.0992 times L1. What is L1? Your X. How do we get L1 from your calculator? So you see here, the calculator 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, above 1, you will see a small blue. It says L1. So that's why second 1, that is L1. And then just enter, you will get all those numbers. Okay? So now after you get, again, residuals is y minus y hat. So meaning that is L2 minus L3. So after you get that, is you go back to like a scatter plot. So second y equals 1. And then on L1. So you have to change this. Instead of residual, it's going to be, what do you think?
L3.
L4. Because our residual is in the column, the fourth column, right? And then zoom 9, you will get the plot. That's the residual plot. Questions? Again, you only do this if you don't have this calculator. You only do those, you add those 2 columns if you don't have this calculator. Okay? Any questions?
No.
How about others? Don't be shy. No questions?
No.
Okay. Sorry, I was reading the chat. Yes, the discussion is about chapter 4 and 5.1. That's correct. How to get into the X and Y list? It's like the scatter plot. So second Y equals 1. So it's like it's the same steps for scatter plot. Second Y equals and then 1. So I'm gonna go back here. So second Y equals 1 on. So that's the X list, Y list. Okay. All right. So let's go back to our so let's go back here. So if you want to check again the steps on how to get the residual plot, this is those steps using TI-84 plus. Okay, so you will see this, and that is correct. That's what we did. Okay. So next one is construct and interpret residual plots. So you know how to get the equation of the line, right? As always, I told you the same shortcut for the whole chapter 4, StatCalc 8. And y is equal to a plus bx, you should be able to get the slope and the intercept. So influential point. So copy this, is a point that when included in a scatter plot strongly affects the position of the least squares regression line. So this is a perfect example. So look at the blue line. That is a least squares line for 48 states. So you see all those blue points. And when you get the equation of the line, so this is the line. So consider scatter plot of farmland versus total land area for United States. For US states, the blue solid line on a plot is the least squares regression line computed for the 48 states, not including Texas or Alaska. So 48 states, not including Texas or Alaska. So if you include Texas, 49 states. So imagine without this blue line and including Texas, so that's now 49. Including Texas moves the line somewhat. So you will see that dotted lines, the red one. And the green dash dot line is the least squares regression line for 49 states when you include Alaska. So including Alaska causes a big shift in the position of the line. So that's why we consider this like Alaska is very influential, because when you include Alaska, your line is going to be like this. Without Alaska, this is your line. So that is very influential. So issues with influential points. Those points are troublesome because the least squares regression line is supposed to summarize all the data rather than reflect the position of a single point. And when a scatter plot contains outliers, the least squares regression line should be computed both with and without each outlier. You have to check it to determine which outliers are influential. If there is an influential point, the best practice is to compute the equation of the line, again, both with and without the point. So that's why if you go back here, So imagine without the lines and with all these 50 points. It's obvious here that Alaska is an influential point, right? That's far from the rest of the points, right? So we consider this an outlier, an influential point. Same thing with Texas. So that's why you can compute the equation of the line with and without those. And you're going to do something like that for, I think, for the discussion. Okay, the last one, compute and interpret the coefficient of determination. So again, let's go back to all the points that we use the past days, and you know how to get the equation of the line. This is the equation of the line, and this is the residual plot. So about all this, explained difference and unexplained difference is each point, the distance from each point to the line. Let's say this point here, the distance from this point to this is what you call the unexplained difference. So when you get the difference of the y values of these two, we call that unexplained difference. And then when you get the difference from this point on the line to the mean of all your y's, this is the mean of all the y's. That is what you call the explained difference. When you get a difference between the values of those y's. So that is y hat minus the mean of y. And this one is y minus the mean of y. But don't worry, I'm not going to ask you to do that for all the points. So I'm just showing you how to get those explained and unexplained difference y's. And the reason why we need that is to get your r squared, which is what you call the coefficient of determination. So the coefficient of determination formula is explained variation over unexplained variation plus explained variation, or explained variation over the total variation. And again, you don't need to memorize this formula, because all you have to do is using the same example here. If we go back to our graphing calculator, so what we always do is enter our x and y here, right? L1 and L2. And like what I said, to get the equation is stat calc 8. You always do this for the whole chapter 4. So L1, L2, make sure that you have L1, L2, not L3 or L4, or wherever you enter your x and y values. Then calculate, look at that. You already have the coefficient of variation. You have the answer for r squared. Easy, right? So meaning stat calc 8, we need that for 3 things. First, r, that's from 4.1. We compute for coefficient of correlation coefficient, that is 0.91, 0.9006. And then to get the equation of the line, we use a and b, and we also use that for residual plot. And coefficient of determination for 4.3 is r squared. R squared is coefficient of determination. So you will see a problem like this. What's the coefficient? Compute the coefficient of determination. All you have to do is, again, stat calc 8 and look for r squared. Any questions? Any questions? But don't ever forget this. Whenever you need that R squared, let's say if you did reset your calculator, don't forget, let's say, I'm not gonna reset this. Don't forget mode and then stat diagnostics. Make sure that it is on. Okay? Any questions? Or if you're using other TI graphing calculator, go to catalog, so second 0, look for diagnostics. So you go down and look for diagnostic on, then enter, and it's on. Okay, because some graphing calculators, when you press mode, you don't see stat diagnostics. So to do that, so second 0, look for diagnostic on. Okay? Any questions?
No.
And that's it for 4.1. Chapter 4, sorry, 4.3. And let's have a quick example. So you should be able to finish your homework. I believe I give you 20 problems. Chapter 4 and 4.3. All right, so let's try number 23. So please get your calculator and enter these numbers into L1 and L2. And then, so hot enough for you, the following table presents the temperature in degrees Fahrenheit and barometric pressure in inches of mercury on August 15 at 12 noon in Macon, Georgia, when over a 9-year period. So letter A, compute the least squares regression line, meaning the equation of the line. So try it. So remember the shortcut statcalc 8, and you should be able to get A and B to write your equation of the line. And let's use 4 decimals. And let me know when you have an answer.
I got 740.3765 minus 21.8708x.
8708x. Thank you. That is correct. And letter B, look at this, coefficient of determination. Meaning this is r squared. So on the same page, on the same screen, when you did StatCalc 8, you should see r squared. And that is
0.3225.
so coefficient of determination.
I'm sorry, do you mind repeating what you pushed to get there?
StatCalc 8.
It's R squared on the same number 8.
So StatCalc 8. What's the answer again? Sorry.
0.322.
322.
Okay. Yeah. 3225.
So let's round it up. For r and r squared, let's use 3 decimals, okay? Yes?
So 0.323. Yes. Right.
Okay. All right, so next, scatter plot, you know how to do this. Second, y equals 1, turn it on, and then make sure that your x list and y list, L1, L2, and then do that, and zoom 9. Yes, StatCalc 8. All right, so you should be able to see a scatter plot for letter C, okay? Now, do you see an outlier?
Yeah, the first one, 30.16. The top left on the scatter graph. Scatter plot.
Which one is the outlier based on your scatter plot?
The first one,
I didn't hear you, sorry.
the first one, 30.16 with temperature 80.1. The first one.
Say that again. Which one? Sorry.
The first row,
The first,
30.16 with temperature 80.1. The first one.
is that the outlier?
Yeah, it was right at the top. On my scatter plot, it's right at the top left, away from the other dot.
What? Okay, how about try to enter this into y equals and then graph the line. So y equals, enter this 740.3765 minus 21.8708x.
Oh yeah, I'm sorry, I had the wrong. I had the previous one.
So to get the outlier, that is the point that is far from the line, not the point far from the other points. So the point that is not close to the line. And that point is, Michael, that is correct. So 29 should be the 29.83 and 94.5.
Are we supposed to be able to tell that just by looking at the graph, or do we have to punch it into the equation?
Well, by looking at the graph, just like this. So let's say, for example, I don't see a scatter plot. So let's say if you have these points here, say here, and if you draw, if based on this, if you draw a line, so among these points, you can see that this is far from the line. Do you agree?
Yes.
So possibly this is an outlier. So let's say also, let's say you have a point like here. So that is an outlier because the rest of the points are very close to the line.
Okay, that makes sense.
So even without this, by just looking at the points, you should be able to see which, if I draw a line, I know that the line here based on the points is going to be positive. It's going to be, should be something like this, right? By just looking at the points. But based on these points, this point is far from the line. So possible that it is an outlier. Okay?
Got it. Thank you.
Yeah, no problem. Okay, so what I want you to do next is remove the outlier, go to your table, your L1 and L2, delete 29.83 and 94.5. So just press delete. Are you done? So when you delete the outlier, what you're going to do next is scatter plot again. So second y equals 1 on zoom 9. And then you should be able to have a new equation. So stop calc 8. You should have a new equation after deleting 29.83 and 94.5. Did you do it? What's the new equation?
Uh, 320.5388.
Let's use 4 decimals.
Yeah, it's 5388.
Oh, 538 is. Sorry.
That's
5388. And then
minus 7.8999.
okay, so don't forget the x.
X, yes.
Now enter this into go to y equals. Enter this into the second, you see the second equation. And then you should be able to then graph it. What do you see now?
I see a line going through the dots.
Yes. How about the rest? Were you able to follow? Yes, yes. All right. So now when you remove the outlier, what do you see with the dots and the line? Are they all very close to the line? Yes, right? So that's why to answer letter F is that outlier and influential. Do you have more outliers now? What do you see? Because I don't see I don't see a scatter plot. So when you try it, what do you see?
So I see the where it's plotted, but as the line goes through, I got 2 dots in the back and then 2 dots in the front. I was just wondering if those other dots that aren't grouped together, if those are outliers, like how we had the one that was up at the top, or is it essentially the equation done?
Okay.
I'm not saying there is an outlier. I'm asking do we still have to remove for the outliers, or are we done with our equation?
No. So the question is, do you see based on the graph of those points? Do you see an outlier?
No. I don't, right? I was just asking because there is a couple points that are still away from the line. And I was just wondering if those were other outliers or if essentially we were finished with our equation.
Okay. I'm just gonna show you everything. Let me type the numbers. $29.86. Sorry, 29.86. 85.5, 87, 94.5, 84, 83.2, 80.1. My zero is not 80.1, 84.9, and 84. 84. So to scatter plot, so second y equals 1 on, and then zoom 9. So here, to get the equation of the line, stat calc 8. Wait, is this the same thing? No. Yeah, it's the same thing. And then if I type the equation of the line here, 740.3765 minus 21.8708x. Oh, 740.3765 minus 21.8708x. When you graph this, so here, based on this, which one is the outlier? We said
The one at the very top, that'd be that 29, where's my paper? It'd be the one at the very top,
29.
0.83 and 945.
We delete this, and was it 94.5?
Yes.
Yes.
Okay, so if we delete this, and let's try again a scatter plot. Zoom 9. Oh, wait. We have a new equation here. What was the equation again? We forgot. Stat calc 8. Is that the right one? Yeah. 320 point.
5388.
5388 minus
7.8999. X.
x. Thank you.
Did you have to delete the first equation, or would you be able to like write it down at the bottom, like option, like the Y2, I believe?
Oh, sorry. So let's try. What was the equation again?
It was 740.3765 minus 21.8708x.
7.
Sorry, 8708x.
And also, we can check what happened if we have so yeah. Okay, so look at this. So these are all the original points, all these points, right? And our first line was the red one. And as you can see here, that it looks like that this point is an influential point, right? And then we remove this, we remove the point. The point is the coordinates 24.83 and 94.5. So when we remove this, you have these remaining points. And then when you get a scatter plot and the new equation of this points here, and you plot the line, the equation of the line, this is which is the blue one, this is the new line. Why do we remove 94? 94.5 is part of this point. Okay, what was the question again?
I think the original one was the same thing I've been wondering. Once you have your new dot plot without the outlier, some of them still kind of look far from the line. How far away from the line should we start being suspicious?
Good question. Yeah. Like this was the original. So when we remove this, I guess you're asking when we remove it and this one now. Without the red one, right?
Correct.
Did I delete the red one?
So like one of them looks way high and one of them looks way low because they're both semi-equal distance. I mean, is that why we don't think they're outliers?
Oh, I see now your question. That was Michael's question too.
Yes.
Yes, about this. You talk about these 2 points here, right?
Yes.
Let me get the other one. I never encountered a problem with outliers from removing an outlier. But that's a good question though, that it looks like this is far from the line. This one is not.
Will, when asked a question, will we always know how many outliers we're looking for?
Let me what do I remember about the problems? Yeah, if there's a question about something like outliers for a quiz or a test, I'm gonna tell you if there's one or two.
Gotcha, okay.
Okay. All right, and we have one more question about this problem. What is the coefficient of determination of this new one? How do we do that again? Coefficient of determination. So stat calc 8. And if you don't see R and R squared, remember you need to go to your mode stat diagnostics on. So turn it on and then go back stat calc 8. So the answer is 0.113. So coefficient of determination is R squared. Any questions? Any other questions? Any other questions? No? All right, it looks like we don't have time for chapter 5. So meaning I'm not gonna, I don't wanna start with this other remaining 30 minutes, 35 minutes for chapter 5. So meaning I'm not gonna include chapter 5 on the quiz. Is that okay?
Yes.
So meaning we're just
Yes.
gonna
Yep.
just focus on the quiz it's just about chapter 4, and definitely I'm gonna change the discussion and remove chapter 5. Remove chapter 5.1. Okay. So
Yes.
meaning the discussion is if I'm sure some of you already checked the discussion. Only you're just gonna work on 3 problems. So I'm gonna show you now the discussion points here. So that is a perfect actually. So I can remove a chapter 5 from this module and make it a separate module. Sorry, that's my cat. So here I'm gonna remove edit. This is just a chapter 4 discussion, and I'm gonna remove these problems to solve, and meaning add groups 4.1. I'm gonna remove chapter 5 and remove chapter 5 here. So what we're going to do is I'm going to explain for the remaining minutes. I'm going to send you to a breakout rooms and try your best to answer. Like you choose with your team, choose one problem for each 4.1, 4.2, and 4.3. There's assigned one problem for each section from 4.1, 4.2, 4.2. This is a review for your quiz on Monday. Okay, so breakout room, if it's an odd number, you answer these problems. It's an even number, you answer these problems. And then let's change this to Thursday instead of tonight. Okay, so by Thursday, tomorrow night, you only need to respond to this discussion with your answers for one of the 3 problems. Did you get that? So with your group, you're going to answer 3 problems. And then for you, you reply with this with just 1 problem. So I want, let's say if you are 5 in a group, I don't want all of you to use the first problem. So make sure that at least some of you use the first, the second, the third. Okay? Then you can reply to at least 2 of your classmates' answer by Sunday at 11:59 about the other problems that they solve. Let's say you try it on your own, and then when you see, oh, it's wrong, maybe how about you try this, or you can ask that person, how did you solve this? Okay, so you can at least 2 of your classmates reply at least 2 by Sunday at 11:59. So it's better, that's why it's Thursday. I want Thursday the first reply, so that the rest of you have time Friday, Saturday, Sunday to reply to all of your other classmates' responses. Okay, if you see a question that you need to show a scatter plot, don't do it, because I don't want you to spend a lot of time to take a screenshot and then attach it. Okay, sounds good? All right, I'm gonna send you to a breakout room now.